Here we are reacting sodium thiosulfate with water, well, dissolving sodium thiosulfate in water. So we need 25 centimetres cubed of our water to start with. Okay, and I'm going to pop that into my boiling tube. We need to establish the temperature before mixing. So we pop our thermometer in there. And we can record 21.0 degrees there. Now I'm then going to add my sodium thiosulfate. So I've weighed this out already in the weighing boat there. We're going to add that in and we're going to stir it until it's dissolved and record the lowest temperature reached this time. I'm also going to put that data logger in so that we can visually see the temperature change as we go. Okay, right, so we'll pop that in there. We'll start recording so we can see our initial temperature as well, and you've recorded the 21 degrees from the thermometer there too. Now this one's dropping a little bit to start with. I've just taken this out of the exothermic reaction, so I think it was still a little bit on the warm side, so it's just cooling down. So if we just give it a couple of seconds to establish a nice base temperature there to make sure it's not dropping any further. So we just want it to be the temperature of the water, so we've got a nice steady baseline. There we go. Can we see that it's just, or just about, we've wibbled down again there, it's just about static there. Okay, so I'll pause you for a second just while we allow that to become a steady temperature. Okay, now ready to mix. So lift these out of the way, so I've got some space. Put this down the side. And then do some stirring. So we can see straight away on the data logger screen that the temperature is plummeting here. Looks a bit more dramatic than it is in terms of actual temperatures, but we'll see. What are we down to? Oh no, we're about 16 degrees. That's dropping fairly low. So I'm going to keep stirring this. This is probably going to end up in saturated solution, so we're not going to end up with all our solid dissolved. There's a fair old amount in there, but we will get the maximum amount of reaction possible happening. Then the data logger is very useful because we can see quite easily when the temperature is not really changing anymore as well. Okay, so what am I down to here? 15. So we'll just give it another minute to see if we can get any further change. Good old stirring there. No, down to 14, so a bit more. There, I think I can read that one off as, yeah, 13.0 there. And one more minute to see if there's anything further. That's starting to head back up a little bit now. So I think our lowest temperature reached there is going to be 13.0. So can you please record that in your table? And then you might like to think why it's starting to go back up a little bit this time. Okay, so we can keep an eye on the data logger version as well there. We might be able to see that in a bit more of a visual way. But certainly on the thermometer, it's starting to increase a little bit now. Okay, make sure you then record what happened in terms of the temperature, and then you can classify this kind of reaction. And in our final reaction here, we're going to react sodium hydrogen carbonate with hydrochloric acid. So I've measured out the hydrochloric acid already. And I'm going to put my thermometer back in there. And then this time we are going to add 2 spatulas of our sodium hydrogen carbonate here. And again, stirring and recording the lowest temperature reached. And again, we'll pop our data logger in so that we can visually see what's going on. So our initial temperature here is 21 degrees again. So record 21.0 degrees there. I will start the data logger here, and we'll just again let that pause for a minute so that we can reach a nice steady baseline temperature. So it's just allowing the data logger to take on board the temperature of the hydrochloric acid there. And then we'll add our 2 spatulas of our sodium hydrogen carbonate here. Okay, so let me just move this to the side. There we go. That's kind of fun. Should I put another one in? There we go. So we've got plenty of reaction going on there. So you might like to think about what you have observed. Okay, so your first question says, what did you observe when the sodium hydrogen carbonate was added? So I think that was fairly dramatic and fairly obvious. So looking at my thermometer here, my temperature is about 18 degrees at the moment. So we'll just keep an eye on that. There's still a very small amount of effervescence going on in the tube there. Still just 18 degrees. And we can see from our data logger as well there that we have got a fairly static temperature. So that would suggest that the reaction has completed. So yeah, if you can record 18.0 degrees for the lowest temperature reached there, and then you can be working out your temperature change. So given that we've reacted sodium hydrogen carbonate, have a think about what gas it is that we're going to be produced. So you can put your answer down in number 2. And while you're writing that one, I am going to get ready to test for the gas. So please also write down how you would think you would test the gas, and then we'll see if your thoughts were right. So to test our gas, hopefully you decided that the identity of your substance was probably going to be carbon dioxide. If you think sodium hydrogen carbonate, leading us to carbon dioxide there. So to test for our substance, we can bubble our gas through lime water. So I have got some freshly prepared lime water here. So we'll pour some of that into our boiling tube there. And then we'll have our reaction this time going on in our test tube, and I've got some rubber tubing and a bung there so we can bubble directly into our lime water. So we'll just start it all up again. So we've got our hydrochloric acid, pour that into the test tube here. I will then add a spatula of the sodium hydrogen carbonate and then pop the bung on quickly. Whee. Nice. So you saw your effervescence as I added the sodium hydrogen carbonate. Then we saw the bubbling coming in here. So that was the gas passing all the way through the tubing down here. And you can now conclude from the colour change. So our lime water has gone really nice and cloudy there, and you can conclude what your gas is. So to complete the sheet, can we now have a word equation for our reaction? So sodium hydrogen carbonate reacting with hydrochloric acid, forming the gas we've just decided here, and you can have a think about what else might be formed there. For our first 2 endothermic reactions, we were looking at measuring a temperature change and looking for a reaction that has a drop in temperature, indicating that your reacting particles are taking in heat energy from the surroundings, so from that solution. And so that solution is losing heat energy and decreasing in temperature. So what we're going to look at here is a reaction where we are actually physically putting in heat energy in order to cause a reaction to happen. So what we're going to do is take some of our green copper carbonate powder here. I'm going to pop this into my boiling tube, and then we're going to heat it and see what happens. And then we are going to test any gas that might be produced by bubbling it through some lime water. So we start off with our nice green powder here. In my test tube over here at the ready, I've already put some lime water. So I'd like you to watch this as we heat it. So this is putting in heat energy. So our source of our heat energy here is our Bunsen burner. So we're putting in our heat energy to cause a reaction to happen. Now when we heat carbon dioxide, when we heat copper carbonate like this, it's not actually reacting with anything. This is just causing it to break apart. Okay, can we see inside the tube here? So it's going black, and can you see there are kind of little mountains, little kind of jumpy bits here of our solid. So this is the solid particles bouncing up and down. Now the reason we've got the movement here is because in our reaction we're giving off a gas, and the gas is effectively blowing these really fine particles up and down as it escapes. So we've heated quite a lot there. I'm going to now suck up gas that could be over the surface of our reaction mixture there, and then I'm going to squidge it up and down in the lime water here. Okay, can we see a change there? There we go. Okay, so we started with our green copper carbonate. It is now black, and we gave off a gas that turned lime water milky in the process. So you can think about what that is. If you look carefully, there's still some little bits of green in here, so if we heat it again, we could have a little bit more reaction going on. I'll do that again because it's quite cool watching all the particles bumping up and down there. Look at that as we go. The gas escaping. And then those particles just drop back down again once the reaction has subsided. There we go.